Hello and welcome to a nostalgic ramble with me. We are currently busy going through IEB's paper 1 from May 2024, and today we are focusing on question 9a. In an arithmetic sequence, the first term is negative log base 3 of x, and the common difference is log base 3 of x. Determine the value of x if the sixth term is 12. Okay, so arithmetic sequence means that so the information we have is that the first term is negative log base 3 of x, and then the next term is going to be negative log, I should actually label what I'm doing instead of just writing random things that have no meaning. Okay, so second term is then log base 3 of x plus the common difference, which is then going to just be 0, right? And then the third term will be 0 plus the common difference. I don't know why I'm doing this, but I'm just getting a feel for the sequence because it is immediately very strange to me. So term 4 will be term 3 plus the common difference. So that is going to be 2 log base 3 of x. And then term 5 will be term 4 plus the common difference. And so it goes, and so it goes. So really, this is the same as 1 log 3x, log base 3 of x. This is the same as 0 log base 3 of x. And this is the same as negative 1 log base 3 of x. So let me just put this into one line or shrink it even. Okay, so that's just the good to know happening on the side there. So determine the value of x if t6 is 12. Okay, so I'm gonna go about this two ways, I think. So the first way has to do with this pattern that I've picked up over here, right, where term 1 is negative 1 of these, term 2 is 0 of them, term 3 is 1 of them, term 4 is 2 of them, term 5 is 3 of them. So it only makes sense that term 6 will be 4 of them. So 4 log base 3 of x, and so therefore 4 log base 3 of x is equal to 12, which means log base 3 of x is equal to 3. And so the question we're asking ourselves is 3 to the power of 3 gives me what? 3 to the power of 3 gives me x. So yeah, if we rewrite this in exponential form, x is then equal to 3 to the 3, which is 27. So that's one way we could do this. The other way that we could do this is we could just, I imagine we can just solve like any other arithmetic sequence, if you use the formula. So we know that a is negative log base 3 of x. We know that d is log base 3 of x. We know that t6 is equal to 12, and obviously then n is equal to 6 if we're looking specifically at term 6. So using the arithmetic formula that tells us that, okay, tn is a plus n minus 1 times d, we can then replace, we can speak specifically about term 6 because that's the one we have information about. So term 6 is equal to a plus 6 minus 1 times d, which is just the same as 5. Okay, so a plus 5d. And we know that term 6 is 12. And a is negative log base 3 of x. And d is log base 3 of x. So this is 5 log base 3 of x minus log base 3 of x. So that's going to be 4 of them, as we found before. So that's another way to arrive back at this equation over here that we had there. So that would be another way to do it. Yeah, I'm not entirely sure of another way to do it. Yeah. Of course, then it's always useful to test these things just to make sure that it does indeed work. So if we use x is 27, then a will be minus log base 3 of 27, which is minus 3, right? To what power do I need to raise 3 to get 27? It's 3, and then that minus is that minus over there. So then the first term will be minus 3. D will be log base 3 of 27, which is just 3. And so the question is, will our sixth term indeed be 12? So if we start at minus 3 as our term 1, and then we add 3, so the next term will be 0, and then we add 3, and we add 3, and we add 3, and then our sixth term is indeed 12. So that checks out. So that looks promising. So let's see what the memo has to say. I haven't even opened the memo. My goodness. So give me a second or 2 or 3. Question 9a. Let's see what you guys have to say about your skills. So x is indeed 27, but this approach looks very different from mine. So let's have a look. Okay, so the first approach, they use the arithmetic formula, like we did in attempt number 2. I can call it that. I'm really resisting looking at the answer to the next question, so I just need a moment to to scroll it out of view. Get out of my mind, get out of my head. Okay, the next approach starts out the same way. They use the arithmetic formula. Okay, so then here's an interesting thing that they do in the second approach. In the second approach, they use the laws of logs to rewrite this as one logarithm. So they take this guy and they say this can also be written as log base 3 of x to the minus 1 plus log base 3 to the of x to the 5. And when you add logs that have the same base, you can just times I don't know what we call this, but yeah, you can times those things. So it will be x to the minus 1 times x to the 5, which is log base 3 of x to the minus 1 times x to the 5 is just the same as x to the 4. That bracket is wholly unnecessary. Okay, right, and then from there, you can rewrite that as 4 log base 3 of x. So that would take you back to this equation. Or what they've done as well is they've kept it at this, and they've said, well, we know that this situation is equal to 12. So let's go ahead and solve. So we are saying 3 to the power of 12 is equal to x to the power of 4. We could then hypothetically take the fourth root on both sides, and because it's an even root, we'd have to consider both the positive and the negative root. But now we also need to think about x and the restrictions on x. we know that x always has to be a number greater than 0, just by definitions of logs. So we shouldn't consider the negative square root here, because then we'll get an invalid answer. So we'll just consider the positive square root, not square root, fourth root. Okay, right, so we do that, and then we have then x is equal to, this is the same as 3 to the 12 over 4, which is 3 to the 3, or you can also just kind of see that if you take 3 to the 3 and times it by itself 4 times, you're going to get 3 to the 12, that also works. And then, you get your x is 27 that way as well. So many ways to conquer Rome. Thank you for coming through, and I hope we will catch up again another time.